I will reserve the lecture time next Wednesday for the additional office hours, so that you will be able to ask the questions related to the final exam. Okay, and also there will be some one last homework which will be due next week. For the deadline of the last homework assignment, I cannot extend it. I need to upload the solutions for the class immediately after the deadline, so that you have time to review the solutions and try to use these materials to prepare your final exam. And that will probably be all the things I want you to know. Basically, we will have 2 lectures left this week, which will help. I'm going to use them to conclude the topics in the route survey. Do you have any questions about it? If not, I will start the lecture today and try to cover as much as possible. Okay. If you don't have any questions, I will start lecture today. In the meanwhile, if you have any questions, just feel free to raise your hand or leave your message in the meeting chat. I will go back to check all the questions. Okay. Okay. So last week we went through the introductions about the route surveying by checking how we're gonna lay out the a curve, and we are provided with the angles of the arc, the radius of the arc, and utilizing these 2 informations to calculate the length of the arc, the locations of the start point at the point of the curve, and the end point, the point of the tangent for the arc, so that you can draw a curve to connect the 2 straight lines smoothly. And also, we went through the method to find out the locations of the stations along the route, along the straight line, and along the arc, based on the deflection angles. There are also some other methods. You can use the total station to identify the locations of the stations on the route, and also utilize the total station base to find out the offset. You can also use the total station to find out deflection angles, and all through some random control points and so on. So those would be the general method applied for you to lay out the curve. But the issues, like for the topics we introduced previously, it only focuses on single radius, which means that the curvature, the degree of the curvature for the arc will be the same for the curve. In reality, there will be many different requirements due to this could be restricted by the areas where we can construct the road. It could be restricted by the smoothness requirement of the driving behaviors on the road, and they could also be the special requirement from the pavement constructions. And those will require us to set up the arc with different curves, with different degree of the curves. And for example, we probably want the degree of the curve to be large when we just enter the arc. In that sense, the road is smooth, the connection will be smoother, and then gradually increase the degree of the curve to make sure that the curvature is larger, and then you can make a turn, left turn, right turn, or U-turn on the road. This will require us to have multiple degree of the curves for the construction of the road, or the horizontal curves. And this type of the surveying this type of the development is called the compound curve, where we will apply two or more simple curves and connect them together to merge two straight lines. The figure here shows one simple example where we have the compound curve with two different curvatures. The one on the left, has the radius say R1, which will be obviously larger than the one on the right, R2. And we also are provided with the angles of the two arcs. One is with the radius R1, the other one is radius R2. And these two curves, two arcs, are designed to guarantee that the straight line A to V is tangent to the arc A to D. In the meanwhile, we want to make sure that the line C to V is also tangent to the arc C to D. With that, we will have the information about the right angles, which will represent the line from the center of each arc to the tangent point. In addition, these two arcs will be connected at the point D, and at the point D, if we draw the tangent line, this line should be which is A prime B prime in this figure. This line should be tangent to both arcs. So tangent to arc AD and also the arc CD. It also indicates that the line A prime B prime should be perpendicular to the line A prime D, and also the A prime B prime is perpendicular to the line B to D, and B prime to D, and also A prime D and B prime D are the same line. So this is the way for us to construct a compound curve, where there will be the way we are able to connect two curves with different radius. For the design, we are provided with the radius of each arc and also their angles. For the arc 1, that is A to D, we provide the radius R1 and I1. For arc 2, which would be the arc C to D, we provide with the radius R2 and the angle of I2. And we want to use this information, using these two information, to find out the location of the point D, and also the distance from the tangent point to the vertex or the intersections of the two straight lines. So what we want to do is we want to find out the distance of A prime to D and the distance from B prime to D, where we will be able to identify the location of A prime and B prime. Usually the A prime to D is the same to the distance of A prime to A. This can be obtained by just considering the arc A to D. And if we can refer our previous analysis, we know that this distance would be R1 times tangent of half I1. And similarly, you can find out the relationship of B prime to C. That is R2 times tangent half of I2. And we can further utilize this information to calculate the the deflection angle between the line A to V and C to V. So this would be the deflection angle. So for the A to V and for A to V and the C to V, the deflection angle is it's quite straightforward, which is just I1 plus I2. And now we have all this information. We know the deflection angle of these two lines. We know the distance of A prime to A and B prime to C and A prime to D and B prime to D. The next question we want to, or the next parameter we want to estimate would be the distance of TL and the distance of TL and TR. So this is another important variables, and two important variables we want to identify to construct a compound curve. So to do that, we need to rely on the traverse method, where we will consider the whole project as a traverse project. And this indicates that we will go through the all the straight lines in this project, start from O1 to O2 and go to C, and then connect C to V, V to A, and A back to O1. This is an 5-side polygon, and we know the angles, all the angles, and we can then utilize all those informations to find out the what's the departure and latitude of each line, and with those information we can then identify their locations accurately. And also, of course, we can find out the length of these two lines. So if we go to check the graph, the previous graph, we can assume that the line from O1 to A, so assuming that this one is the as a north, is a true north direction. It's a true north direction. So the azimuth from O to A would be 0, and this is definitely would be the east direction. Then we can find out the azimuth of O1 to A is 0. For the azimuth is 0, and A to V would be 90 degree. So this is because the O1A and A to V, they are perpendicular to each other. So this is 90 degree. You can find out the O to V is 90 degree. And similarly, you can find out the angles of the other lines. Here, the value I would be I1 plus I2, the summation of the angles for the two arcs. Also, you will be able to find out the length of each arc or each side. So from O1 to A, that will be R1. From A to V, that will be TL. V to C is the TR. And C to O2 is R2. And O1 to O2 is R1 minus R2. With that, you can calculate the departure. You can calculate the departure and the latitude. Here, the specified east and west. East is indicated positive, west means negative, north means positive, and south means negative. So you can then calculate the departure and the latitude of all the sides, all the 5 sides. And this is the preparation for the traverse method. And then if you still remember our previous lectures about the property of the closed loop traverse, you know that if we summarize all the departure, the total value would be 0. If we summarize all the latitudes, they should also be 0. And with these two equations, it will give us the way to calculate the value of TL and TR. So I'm gonna show you the quickly show you the how we're gonna do that. So first, let's go to check the summation of the latitude. So the summation of the latitude should be 0, and which means that we just need to consider the these 5 different latitudes. As I mentioned previously, north means positive, south means negative. So what we have is like R1 minus TR times cosine 90 degree plus I plus R2 times cosine 180 degree plus I minus R1 minus R2 times cosine 180 degree plus I1 should be 0. Again, we are working on this closed loop traverse. So with all the 5 sides, and this is the north direction, and that will be the east direction. So with that, we can calculate the value of the TR as the function of the radius and also the angles of the arc. So that is R1 minus R2 times cosine 180 degree plus I1 plus R2 times cosine 180 degree plus I divided by cosine 90 degree plus I. So this equation tells you how you're going to find out the value of TR. And similarly, we can apply the summation of the departure. The summation of the departure should also be 0 for the closed loop traverse. And if we put all of them together, you can find that let me see. You can find out the value would be TL minus TR times sine 90 degree plus I minus R times sine R2 times sine 180 degree plus I minus R1 minus R2 times sine 180 degree plus I1. I guess they are also missing the part about the R1 here. No, the departure should be 0, so it should be fine. Yeah, so this should be 0, and with that you can calculate the value of TL, which will be TR times sine 90 degree plus I. This is plus I plus R2 times sine 180 degree plus I plus R1 minus R2 times sine 180 degree plus I1. So with that, you will be able to find out the value of TL. But of course, you need to calculate the value of TR first in order for you to get the value of TR. So this is the traverse method for you to get the information about the compound curve. You can utilize you can calculate the distance of A prime to A, or the A prime to D, and the B prime to D, and the B prime to C to identify the location of point D. You can also identify the deflection angle, and apply the traverse method to calculate the length of all the sides for this closed loop. Especially we're going to focus on the estimation of the length from A to V and C to V. So this is the very simple example about the compound curve. You can also extend this design to more than 2 different radius. Like the radius could be it could have 3 different arcs, R1 with the radius of R1, R2, and R3. You can even have more, 4, 5, or 6, or even make it more complicated. This radius can be changing. The radius of the curve can be changing with respect to the length of the arc, so that you have smoothly changing about the radius. And this is another way to design the horizontal curve, but I will not go through the details about that. This is more advanced, and in the future, if you are interested about some related work about designing the horizontal curve with more complicated or more complicated radius or the degrees of the curve, you can refer to the textbook that I recommended in this class. Okay, so I guess that's all for this lecture. I see there's no question, but I cannot see who is raising your hand. Who is raising a hand?
Yeah. Hello.
Yes.
I was wondering. So we have I1 and I2 in the shape, and then for the formulas, we've derived it in terms. We've derived TR in terms of I1 and I. What's I?
Oh, do you mean the capital I?
Yes.
The capital I is I1 plus I2.
Safety rated. I can wear them in the hatch
Okay.
workshop.
And so,
labs.
all right. So, all right. Yeah. Thank you.
Yes.
Yeah.
And I guess that's the question. Does anyone have any other questions? So basically, this is just one implementation about the traverse ring. So you have to know how to do the traverse computation using the departure and latitude to find out the values of all these variables. For example, if you are provided with TR and TL, you should be able to know how to use this method to calculate the radius R1, R2, or find out the degree I1, I2, and so on. So this is the this equation. These 2 equations will be true for all the compound curves with only 2 radius. But if it goes to 3 or more, it's more complicated. You need to rederive the these formulas. Okay. 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 If you don't have any questions, I will jump to the next topic by trying to finish the horizontal curve. Okay. Okay. Now we're gonna switch to the next lecture, the Node 16, about the horizontal curve, and there will be another topic. This will be related to the intersections of the curve and a straight line, or the intersections of 2 curves. This happens a lot, especially for the transporting system. If we consider a curved road and at a certain location, you will intersect with another straight road. You will need to build an intersection at that at the crossing point. And how to identify the location of the crossing point is another issue we need to do before we actually conduct the field construction. So the lectures here will tell you how to do this calculation and what kind of assumptions we're going to make for this specific problem. So I call this one as the intersection, and we're going to focus on the part about connecting a straight line and find out the intersection between the straight line and then the curve. For example, here let's consider a straight line x to p prime. This is in a straight line. And we also know there are two lines. See that is B prime to B, A prime to A. So we know two lines, A prime to A and B to B prime. And we want to find out in the arc which can connect these two lines smoothly. That will be the arc A to B. And we need to find out the intersection of xp prime, the straight line, and the arc A to B, which means that we want to find out the intersection of, find the point P, to which will in both straight line x to p prime and the curve A to B. So in this problem, we are provided with we are given with the information about the angles of the arc. So we are given the angle A to B, which is I in this graph. And we also can find provided with the information about the straight line x to p prime. We know the expression, a linear expression about the line x to p, and we are also able to find out the line from A to p prime. So based on the location of the p and the location of A, we can find out the straight line A to p. And we want to find out the distance, and also, of course, we also want to find out the directions of the line P prime to P, and the angle of theta. So with the theta, we will be able to find out which point we want to identify for P on the arc A to B. So this would be the general assumptions we're gonna provide to find out the intersection. And then let me show you how to solve this one. Basically, to solve this one, we need to consider two triangles. The first triangle is A P prime and N. N would be the intersection between the line X to P prime and the line from O to A. And the other one would be the triangle, OPN. So that will be this triangle. So that's the OPN, and we also need to find out calculate the triangle of AP prime to N. So that will be two triangles we have to consider, and we're going to use this information to calculate the distance of P prime to P and also the angle of theta. So first, let's go to check the triangle AP prime N. And we know that the A is the tangent point. So the angle here, OA to P prime, is in a right angle, and with that we can easily calculate the distance of the distance from N to P prime, N to A and N to P prime. So for N to A, the distance would be A to P prime times tangent alpha, assuming that this one is alpha. Tangent alpha. And for n to p prime, that will be the slope side of the right triangle. So that will be a to p prime divided by cosine alpha. So if we can find out the value of the alpha, you can then find out the distance of NA and the distance of n to p prime. If we go to this figure, alpha as the AP prime n is in the right triangle, so we have alpha plus beta is 90 degree. And if we are able to find out the value of beta, then we can find out the value of alpha. So alpha is 90 degree minus beta. So we're going to hold this one for the moment, and then see how we can find out the value of the beta. Just a moment. Let me try to remove the timing. Okay, so that's the first step. We find out the distance of n to a and distance from n to p prime. And now we will need to find out what's the distance from O to n. And that one is relatively straightforward. For the distance from O to n, it will actually equals to O to a minus the distance of n to a. O to a, we know that is the radius of the arc, so r, and n to a is a to p prime times tangent alpha. This is what we calculated. So that with that we have the information. We have distance from O to a, and now let's go to check the angle of OPN. So for the angle of OPN, we have the for any angles, for any triangles, for the triangle OPN, actually for any triangles, it has the function, it has the relationship, say that A, B, C, if we have the alpha 1, alpha 2, and alpha 3. For any triangles, you can derive the relationship as A divided by sine alpha 1 should be equal to B divided by sine alpha 2 equal to C divided by sine alpha 3. So it's the ratio between the length of the side and its relative the angle should be the same for all the sides. And this is the property of the triangle. So I will not go through the derivation about this one, but we can apply this property for the triangle of OMP or OPN. So with that, we can get ON divided by sine ON divided by sine phi, which will be the this angle, should equal to MP divided by sine theta, and should equal to R divided by not R, just write down the O to P divided by sine sine 180 degree. So this one is 180 degree minus beta. 180 degree minus beta. And we know that O to P is just the radius of the arc. So we can quickly remove this one as the radius of the arc. And for now, we can then derive the relationship between all those angles. What we can find is like just a moment. Just a moment. It looks like it's freezing. Let me try to adjust it for a while. Okay. So it's working now. So with that, we can derive the relationship. The relationship as sine phi equal to sine phi equal to ON divided by R times sine 180 degree minus beta. And you should know that the for the sinusoidal function, sine 180 degree minus a beta, it's just the sine beta. So we can then simplify this formula. So that's one thing. And we also know that beta alpha plus beta is 90 degrees. So beta is 90 degree minus alpha. And so that's the one. Beta is 90 degree minus alpha. And we can also go to just using this information to find out the value of phi. And what's the value of the phi based on this equation to find out value of the phi. And then for the angle of theta, it should be beta minus phi, because the if we go to check the property of the triangle, and you can see that beta equal to phi plus theta. So with that, we can get the information. Beta is 90 degree minus alpha, so theta would be 90 degree minus alpha minus phi. So that's the that's what we derived about the angle of the theta. And the one last thing is about the calculation of the distance from N to P. So from N to P, you can still recall these equations. So N to P equal to R times sine theta divided by sine beta. And once you know the value of N to P, you can then find out the distance from P to P prime, which is just N to P prime minus N to P. So this is what we can estimate about the distance from P to P prime, as well as the value of theta from this derivation. So with that, we can find out the intersection of the straight line from xp to the curve a to b. Here this is just one method for you to do that. We can also apply the traverse method to find out the distance of P prime to P and also the theta. This will be more straightforward. To do that, we will consider the the four-sided polygon. It's not easy to draw it. The four-sided polygon A, P prime, P, n, and we do the traverse computation for all the size for this closed loop traverse, and you can assume that you can quickly assume that the direction from P to P prime is the north direction, the true north direction, so that the azimuth of P to P prime would be 0, and then you can derive the azimuth of, or here it shows the bearing, but you can also find out the azimuth of the line P prime to A, the A to O, and O to P, based on the value of the alpha and theta. And you can also know the distance P to P prime and P prime to A, R, and R. In this formula, we don't know the value of the distance from P to P prime, and also we don't know the value of theta, but we can find out the value of all the other variables. From A to P prime, you can calculate it based on the directions of A to V and the line of X to P. And you can also find out the angle of alpha by checking the directions of the two lines, P to X to P and A to P, X to P prime and A to P prime. So for this, with the distance and the direction, you can then find out the departure and the latitude. And of course, you will have the summation of the latitude will be 0. So you need to use the P prime minus P prime A times cosine alpha minus R times sine alpha plus R times sine alpha plus theta equal to 0. And of course, you have the summation of the departure also be 0. So that would be P prime A times sine alpha minus R times cosine alpha plus R times cosine alpha plus theta. That should be 0. And then if we solve this one, I'll not show the details about how to solve it, but if we solve these equations, you can find out the value cosine alpha plus theta should equal to R times cosine alpha minus P prime A times sine alpha divided by R. And you can find out the distance from P to P prime as PA. I guess it's P prime A times cosine alpha plus R times sine alpha minus R times sine alpha plus theta. So this is the with that you can calculate the value of P to P prime, and you can use the arc cosine to find out the value of the theta, and that's what you need to identify the location of the point P in the arc and try to determine the intersections of the straight line and an arc. So this will be the two different methods for you to identify the intersection. With that, we will only have 4 minutes left, so I will stop here and try to see whether you have any questions. Do you have any questions about the these contents? Okay. By the way, if you are working on the calculation, if you are working on the calculation about the alpha, which would be the angle here, and also distance of P A to P prime, you can try to find out the expression of the line A to P prime and X to P prime first. Find them as AX plus BY plus C equal to 0. Say that, and A2X plus B2Y plus C2 equal to 0. So with these two equations, the intersection of these two equations will be the point P, point P prime. And you can check their slope, or if you assume that P to P prime to X is in the north direction, you can use the using the coordination of A and assuming that P prime is 0, 0 to calculate say that the angle of the R prime. Okay, so that's the there will be some questions about the homework. The due is the homework 8, the last homework for the course. Yes, the originally I designed 9 homework assignments, but due to the schedule changes of the class, I actually merged the 1 homework assignment to some of the previous assignments. So now we will only have 8 assignments. That will be the last one. And for the midterm marks, I think some TAs has already finished grading the midterm exam, and some may not finish all of them. I will check with them to make sure that the upload what they have already graded. I remember 2 TAs has already uploaded their result. There might be some grade has not been uploaded, but I will try to check them, confirm that they have double checked the result, the grading work, and upload. Make sure they upload the marks today. Make sure that I try to upload everything today. Okay. Is there anything else you want to discuss, or any other questions? Okay. If no, then that will be all today. And in the lecture tomorrow, I will have I'll try to finish the rest of these lectures, and also reserve probably 15 minutes for the review of the final exam, and possibly give you the last quiz. But depending on whether we have time in the class, if it's not, I will reserve the quiz for the after class activity. As what we did last time, you will have an hour window to work on the quiz of the class, and then just upload your answers, or just work on the quiz in the on Avenue to Learn. Okay. If there's any other questions, I think I will close the meeting today. In the meanwhile, if you want to know anything, just feel free to let me know. Send me email, and I will reply you as soon as possible. And especially during the final week, there will be a lot of requests, and just feel free to contact me, and I will try to reserve my time for the class. Okay, I think that's all. Thank you very much for your time, and I will see you tomorrow.